Good morning, students. Today we will be discussing galvanic cells in electrochemical cells. This is Mariam Al-Cover and we will be proceeding towards our covered topics. This video will cover the following topics of galvanic cell: introduction, figure, construction, working, reactions and applications. Let us move towards introduction. So, in introduction, we will go through the history of galvanic cell and the definition. In history, we will discuss Galvani, Volta and Daniel, who are the three scientists related to this. In definition, we will discuss that in galvanic cell, spontaneous chemical reaction takes place and that generates an electricity. Now we will be discussing history in detail. First of all, the scientist is Luigi Galvani. Luigi Galvani is an Italian physician, physicist and biologist and a philosopher. He studied animal electricity. In 1780, he discovered that the muscles of dead frogs' legs twitched when they struck by an electrical spark. He thought that there was some potential between these and that's why they twitched. So this was an early study of bioelectricity. Next scientist that worked on galvanic cell is Alessandro Volta. He was an Italian physicist, chemist and Catholic. A pioneer of electricity and power, who is credited as the inventor of the electric battery in 1800. He was also the discoverer of methane. Frederick Daniel. The Daniel cell is a type of electrochemical cell invented by 1836 by John Frederick Daniel, a British chemist and metallurgist. Consists of copper pot filled with a copper 2 sulfate solution in which is immersed an unglazed earthenware container filled with sulfuric acid and zinc electrode. Actually, final decision of preparing the galvanic cell was done by Frederick Daniel. First of all, Louis Galvani, then Alessandro Volta, and then Frederick Daniel. They developed the galvanic cell in detail. Due to these three scientists, we term this cell as galvanic cell, Voltaic cell and a Daniel cell respectively. What is galvanic cell? I have discussed earlier that it is a spontaneous reaction which produces an electricity. Actually, the chemical energy is converted into an electrical energy with the help of an spontaneous redox reactions. We will discuss these reactions in detail in the next slides. This is a figure of galvanic cell. Here we have two compartments. One is with zinc electrode and zinc sulfate solution and other is with copper electrode and copper sulfate solution. We also have a voltmeter and a salt bridge. Here we move toward the construction in detail. So, galvanic cell consists of first half cell and a second half cell. First half cell contains zinc electrode and zinc sulfate solution, whereas second half cell contains copper electrode and copper sulfate solution. Copper electrode is dipped in copper sulfate solution and zinc electrode is dipped in zinc sulfate solution. We also have wire, voltmeter and salt bridge. Now we will proceed toward the working of galvanic cell. What happened in the first half cell? Actually, zinc has ability to lose electrons. Zinc atom from its electrode loses its electrons and electrons move through the wire. Zinc plus 2 ions move in the solution. So, zinc electrode acts as an anode and oxidation takes place. Here's the reaction. Zinc loses an electron and Zn plus 2 ions move in the solution and electrons move through the wire. What happened in the second half cell? Copper plus 2 ions from solution gains incoming electrons. Cu plus 2 ions are reduced to copper atom. Copper metal is deposited on the copper electrode. Now what happened? Copper deposition started on copper electrode and it acts as cathode, and usually reduction takes place at this electrode. What is the reaction? Cu plus 2 ions gain the incoming electrons and the copper solid or copper metal is deposited on this electrode. So now we have overall reactions. At anode, what happened? Zinc loses its electrons and an oxidation takes place, and at cathode copper accepts electrons and reduction takes place. Net reaction or balanced reaction can be written like this: zinc solid plus copper 2 ion will give zinc plus 2 ion and plus copper solid. Now what is voltmeter? Actually, voltmeter is an instrument measure electric potential difference between 2 points. So when we put a voltmeter in galvanic cell, it measures that how much amount of current is produced or voltage is produced in the cell. Salt bridge. What is salt bridge and what is the function of salt bridge? Usually a salt bridge is a junction that connects the anodic and cathodic compartments in a cell or electrolytic solution. The salt bridge usually consists of a strong electrolyte which is further made up of ions, silver nitrate or KCl. It prevents the diffusion or mechanical flow of solution from one half cell to another. It prevents or minimizes the liquid-liquid junction potential. It acts as an electrical contact between two half cells. Actually, what happened? In first half compartment, Zn plus 2 ions start depositing. If we don't have salt bridge, then there will be no electrical neutrality, and at the end the reaction may stop. So salt bridge acts as maintaining an equilibrium between two solutions, as here Zn plus 2 ions deposits and here what happened, that we have an electron. So sulfate ions are also present here. So to avoid the deposition or accumulation of charges in both the compartments, salt bridge acts as an equilibrium maintainer, or it will maintain the neutrality. Now we proceed toward the applications of galvanic cell. They are used in watches, clocks, remote controllers, calculators. They are also used in cell phones, cameras and laptops. They are used as fuel cells for engines to power up. They are also used in toys. This is all for now. Thanks for Mariam Al-Qadar, and you can further connect with me on Upwork, LinkedIn, Facebook and YouTube channel.